Hello everyone, welcome to the Security channel. In this video, I'm going to take a few problems from the Berkeley Math Tournament from 2023. In this video, as you can see, some of these problems are going to be related. For example, here we have set 1 that basically deals with two problems, and the solution of problem 2 is going to be related to the solution of problem 1. So we need to solve them in sequence. Let's get started. For problem number 1, it says what is the maximum number of L-shaped pieces, as you see here, that you can fit in this 6x6 grid shown below. And you can assume that we are going to rotate this L-shaped fit to fit the maximum number of possible L-shaped pieces. The problem is really easy. So to do this, I'm going to start with something like this. This is one L shape. And then for the second one, I'm going to do something like this. And then again, I'm going to do this. And for the last one, I'm going to do something like this. As you can see, for the first two rows, I'm going to fit 4 L-shaped pieces. And you can imagine that I'm going to do the same thing for the second two rows and third two rows. So if you consider everything, in total, you are going to have 12 L-shaped pieces fitting in this 6x6 configuration. First, note that the total time for the whole number of problems that we have here is going to be 40 minutes. So you don't expect a very challenging problem here. You just need to think through and then start solving the problem. So the answer to this question is simply 12. And you can say that basically we didn't waste any cell here. If, for example, when you are doing that, you are wasting some of these cells, then you can ask this question that how is it possible to fit more cells here or more blocks here. But here in this case, we didn't waste any cell. So we can say that 12 is maximum. Obviously, you can do different configurations and all of them are going to be valid. Now, based on this 12, problem number 2 is asking, let's assume that N1 is going to be the answer to question 1. So we know that N1 is going to be 12. Now it says suppose N1 plus 1 plus 1 over N1. So we are going to have N1 plus 1 over N1 is written as A over B. Now we know that A and B are relatively prime positive integers and we are going to find A here. So what's the value of A here? Since we have 12, we can do something really quick. So we can say that we are going to have 12 plus 1 over 12 is given as A over B. And then doing some simplification, we have 12 and then 12 to the power of 2 plus 1 plus 12. If you do this, you're going to end up with 157 or 157 over 12 written as A over B. First of all, we know that A and B are positive integers and we know that they are going to be relatively prime. And in this case, we know that the GCD of 12 and 157 is basically 1. This means A is going to be this 157 and that's our answer. Now, based on what we did, we finished set 1. Now we are going to move to set 2, and for set 2, as you can see, the problems are going to be 3 problems and they are all related. So we are going to start from problem number 3. In problem number 3, it says, every day after school, Alice drops 1 marble on the ground. Bob drops 2 marbles and Carol drops 3 marbles. After some days, there are a total of 24 marbles on the ground. And the question is asking how many of these marbles were dropped by Bob. Okay, so we know that we have Alice, we have Bob, and we have Carol. And Alice is going to drop 1, Bob is going to drop 2 marbles, and finally Carol is going to drop 3 marbles. Now, in total, every day we are going to drop 6 marbles. As you can imagine, when we have 24 marbles on the ground, we can say that basically it's been 4 days. So first day, second day, third day, and fourth day. In total, we have 24 marbles on the ground. Now the question is asking how many of these were dropped by Bob. So now if we multiply 2 by 4 days, it's going to be 8, and 8 is the number of marbles dropped by Bob. And 8 is the number of marbles dropped by Bob. Now moving to question number 4, it says, let's assume that N3 is the answer to question 3. So we know that 8 is going to be N3. In this question, we have a house, and the house has N3 doors, each numbered from 1 to N3. So we have a house. The house has N3 doors. So basically we have 8 doors. And the doors are numbered from 1 to 8. Somebody is going to enter a door and exit another door. However, these doors can be the same. The only thing that we know is sum of the numbers on the 2 doors is even. Now we are going to find the number of possible ways that you can enter and exit this house, with the condition that the numbers written on the doors that you're going to use should be even. Now let's see how we're going to solve this. As you can imagine, first of all, we have 2 numbers. Let's say the first number is going to be A and the second number is going to be B. And some of these need to be even. Since we are talking about even and odd numbers, the first thing that comes to mind is basically from these N3 doors, starting from 1 to N3, how many of them are going to be odd, how many of them are going to be even. You obviously can do some math, but here things are going to be easy, so I'm going to show the full picture here. So we have 1, 2, 3, 4 odd numbers, and we have 1, 2, 3, 4 even numbers. So we have 4 odd numbers and 4 even numbers. Now, when you have 4 numbers odd and 4 numbers even, and you want to enter a door and then exit another door, and the number that you have on the first door and the second door needs to be summed and it should be even, you can say that if A is even, then B needs to be even, and if A is odd, then B needs to be odd. How many even numbers do we have? 4. And then, because we are going to use the same door for exit, basically it's possible to have the same door for exit. So in total we are going to have 4 times 4 if the first door is even, plus 4 times 4 if the first door is odd. If you add these together, you are going to end up with 32 as the total number of possible ways that we can do this. So 32 is going to be the final answer. Now let's move to question number 5. Here we have N4 as the answer of question number 4. So we know that n4 is going to be 32. So here we have three circles centered as A, B, and C. We know that the radius of the big circle is n4. So this is going to be 32. And then the radius of the medium-sized circle is going to be n4 over 2 or 16. So this value is going to be 16, and then the radius of the smaller circle is going to be 8. Now we want to find the shaded area. To find the shaded area, I'm going to find the area of the big triangle you see here. Let's assume that this is G, and then it's going to be ADG. So what's the area of ADG? The area of ADG is going to be 32 times 32 over 2, which is going to be 512. Now, what's the area of this yellow triangle? The area of this yellow triangle can be written as 16 times 16 over 2, which is going to be 2 to the power of 7 or 128. And finally, we need to find the area of this, let's say, pink triangle, which is going to be the area of this CFG is going to be 8 times 8 over 2, which is going to be 32. Now, what we need to do is we basically find 512 minus 128 minus 32, which is going to be 352, and that's our final answer. Thanks for watching the video. I hope you enjoyed the content that we have here. If you'd like to see more videos like this, please subscribe to this channel. This is the SQRT channel, and I hope to see you in the next video.